here's our first example of creating a grouped frequency table for a quantitative variable. The table below contains the amount of rent paid every month for 24 students in a statistics course. We're going to make a relative frequency distribution using 6 classes. So for this data table, the individual was a statistics student, and the variable is the amount they pay in rent each month. And rent is a number that it makes sense to do math to. We can imagine that 7 could be the answer to the question, how much do you pay in rent each month? So the type of variable here is quantitative or numeric. And so this is a job for the process that we're learning now. Our first step in creating a grouped frequency table is to calculate the class width. On the last page, we had this formula for the class width. I've just copied it here for easy reference. And so in order to calculate this class width, we need to find the maximum value and the minimum value for our variable. And it can be a little bit tricky to go through a table and make sure that we actually have the maximum value in that table and the minimum value in that table. So here's the technique that I use. I look at the table, I'm finding the maximum value now. I look at the table and I look for a value that jumps out at me as being big. In this case, this 2550 jumps out at me as being a big number. And now I'm going to look through the table kind of systematically and see if I can find anything bigger. So looking down the list, nothing bigger than 2550. Still nothing bigger. I didn't find anything bigger than 2550. So that really is the maximum value. I'm going to write that down as my maximum, 2550. Next, I want to find my minimum value. So I'm going to pick a value that looks kind of small. 690 jumps out at me as being a small value. So I'm going to say that's my minimum value. I'm going to go through and look for something smaller. Okay, not smaller. Oh, 600 is smaller than that. Okay, so now 600 is my minimum value. Now I'm going through and looking for something smaller than 600. Oh, 350 is smaller than that. So 350 is now my minimum value. So I'm going to keep looking. 350 is my minimum. I'm looking for something smaller than 350. And I didn't find anything smaller than 350. So 350 is my minimum value. I'll write that down as my minimum. So this way we can go through systematically and make sure that we've found the minimum value. Okay, so the other number that we need for this class width formula is our number of classes. And in real life, that's something that we often get to choose. In math class, that's going to be told to us as a part of the problem. So in this problem, we were told that we want to use 6 classes. The number of classes we want to use is 6. Okay, we're ready to calculate our class width now. So we're going to have a fraction, we're going to have subtraction. We'll have our maximum value, 2550. Our minimum value, we said, was 350. And our number of classes was 6. And now we can just put this whole thing into our calculator at once. But when we do, we need to put the 2550 minus 350 in the numerator there. We need to put it in parentheses to tell the calculator that what we want to do is first the subtraction and then the division. So here's how that goes in the calculator. We're just going to say parentheses 2550 minus 350, close parentheses, divided by 6. And so on the calculator, we get 366.66, etc. And when we calculate our class width, we're going to always round up. And so we're going to round this up to 367. Our class width is going to be 367. Okay, so the next step is to calculate our lower class boundary. For our lower class boundary, we need to think about what kind of numbers we have in our data set. In this data set, we have whole numbers. So we want to subtract half of a whole number. We want to subtract 0.5 from the minimum value, which was our 350. So we'll take 350 minus 0.5, and that gives us 349.5. And again, the reason that we're doing that is so that after we set up all of our classes, none of the numbers in our table will ever fall on the boundary between classes. So it's always unambiguous which class each number is in. Okay, now we're ready to actually create our classes. That is, to figure out the boundaries of each class. And to do that, we're going to put the 349.5 as our first lower class boundary. And then, remembering that our class width was 367, for each class, we're going to start with the lower boundary and add the class width to that. And I'm going to do my addition on the calculator. And I'm actually going to take advantage of some shortcuts that the calculator gives me. So I'm going to do 349.5 plus 367. So my first upper class boundary is going to be 716.5. Now, my first class ends at 716.5. I want my second class to begin in exactly the same place. So my first upper class boundary just gets copied down to be my second lower class boundary. For my second class, I'm going to take that 716.5 and add another 367. And on the calculator, I'm just going to type plus 367. And notice when I hit plus, the calculator automatically inserted that ANS for the previous answer. So my second upper class boundary is going to be 1083.5. That's my second upper class boundary. And again, I'm going to copy that down. I want my next class to end just where this one begins. And so my third lower class boundary is going to be 1083.5 again. Now, here's where I have a shortcut on the calculator, right? Now I want to do 1083.5 plus 367 again. But on the calculator, I'm just going to hit the Enter key again. And the calculator is just going to do exactly what I did on the previous line again. Take the previous answer and add 367 to it. So my next upper boundary is going to give me 1450.5. Copy that down as my next lower boundary, 1450. 50.5. And then on the calculator, I just hit the Enter key again, and that gives me my next upper boundary, 1817.5. Copy that down, 1817.5. Hit Enter again on the calculator, and that gives me 2184.5. Copy that guy down, 2184.5. Hit Enter one more time and get my last upper class boundary, 2551.5. So that calculator shortcut saves us a lot of copying. We can just hit Enter over and over again to find all of our sequential upper class boundaries. If I'm doing this problem, typically what I'll do is just go down with the calculator and fill in all of my upper class boundaries and then just copy them to the lower boundaries afterward. That way I'm looking at the calculator once and then I'm copying once. Okay, so we have our class boundaries. And at this point, we want to do a reality check. We got 6 classes, which is what we asked for. And our largest value, looking back, we saw our maximum was 2550. Our largest value, 2550, is going to be in our last class, and it's going to be really near the end of our last class. So making that happen, making our largest value be near the top end of our last class, was the reason that we did all of the calculations the way that we did. And notice also that since all of our values are in whole numbers, every value can only be in one class. And making sure that every value is only in one class, that's why we did that subtract 0.5. Because that makes sure that our class boundaries will always be something 0.5. And so none of the values in our data set can ever fall on one of those boundaries. Okay, now we're ready for the last step. We just have to actually count the frequencies. And I have a copy of those class boundaries on the next page. So now we're looking at our class boundaries. And I've made a copy of the data table here, just so that we can look at it while we're actually counting these values. Now, I recommended doing this for qualitative data. It's even more important for quantitative data. The way I'm going to go through this is I'm going to look at a value in the data table. I see 1500. 1500 is between 1450 and 1817. Right, 1500 is between these two numbers. So I'm going to put a tally here. And then, because I've counted it, I'm going to mark off this number. Next, I'm looking at this 1500. 1500 is between these two values again. I put another tally. I mark off this number. I look at 1250. That's between these two numbers. I'll put a tally here and mark off this number. I'm not going to make you watch me go through this entire tally process. You should pause the video right now and go through and do a count on your paper, and then resume the video and make sure that we got the same tally. So the numbers that I get are 5, 7, 8, 3, 0, and 1. Adding all of those up, I have 5 plus 7 plus 8 plus 3 plus 0 plus 1. And I get a total of 24 values, which is what I was supposed to have, right? I knew I had 24 values in my data table. So adding all of these up lets me know that at least I didn't miss one or count one twice. Now, when we did this for the categorical data, sometimes you can kind of get away with just like going through and counting all the Fords, counting all the Chevys, and so on. When we do this for quantitative data, it really is worthwhile to do this systematic go through, count each value, tally it out. This is a time-consuming and error-prone process, and you want to go about it as systematically as you possibly can. Again, when you have your data table on the computer screen, that's a little bit harder. I recommend either making a screenshot and then checking off in the screenshot, or else copying and pasting the numbers like into a notepad and then deleting them as you count them. So that is our grouped frequency table. In the next video, we'll talk about what we need to do to take this grouped frequency table and turn it into a graph.